So I'm John Lambert, Senior Director in Trustworthy Computing Security. There's 9 trends, and the reason there's 9 is because I came to BlueHat to learn the 10th trend. That's why, Mike. So 2010 is kind of an interesting year for me because not only does it mark 10 years of me being in security at Microsoft, but it's a good point to look back at the last decade and see what were the trends in exploitation that influenced that, and then what will the trends be over the next 10 years that will influence exploitation. So with that, I have 9 trends, and I'll go through each one of these today, but you can see them up there. And these are part technological, part social, part other trends out there that I think will influence how exploitation takes place over the next 10 years. With that, let me go ahead and jump in. So the first one is 64-bit computing. The last 10 years were really an era of 32-bit computing, and if you know, how many of you are running a 64-bit OS now? Fantastic. If you look, Windows 7, almost half of the Windows 7 installed base is running a 64-bit operating system, and that is a really great thing. As our customers upgrade, that move to 64-bit is going to continue. If you look back at 2007, Exchange shipped their 64-bit version only, no more 32-bit. With Server 2008 R2, no more 32-bit servers from Microsoft. You can see here we're really on a trend where 64-bit is going to become the default as far as desktop and server class PCs. And how many of you have written shellcode before in here? Yep. So I bet it was 32-bit shellcode. In the future, you're going to be writing 64-bit shellcode. And so that is definitely a trend that we're going to see. If you look at how 64-bit is different from 32-bit from a security point of view, one of the most common exploit techniques is to hijack exception records on the stack. Super common in IE-related exploits. And 64-bit, there are no exception records on the stack. So that whole technique goes away, and exploit writers will have to come up with a new one. Data execute protection, that is something we introduced during XPSP2, and we have been working year after year to get applications ready and compatible and all that stuff with it. And finally, IE8 turned it on by default. Office 2010 turned it on by default. Whereas on 64-bit, it has just been on by default since the beginning. And that's been a really great thing. Also, in Windows Vista, Adrian Marinescu rewrote the NT heap, and he introduced a lot of hardening in it, including this heap terminate on corruption. And that has been something that, because it can cause compatibility issues, as it turns out, we were saying, hey, this is some good security stuff. You're detecting when there's corruption in the heap. Go ahead and let's make that on by default. It turns out a lot of applications on Windows happily corrupt their heap and just sort of keep on muddling through. So for 64-bit, that was a chance where we could say, you know what, there isn't a lot of installed base of native 64-bit apps, so let's have the secure default there. And so it's just on by default for 64-bit. And if you look at a lot of the exploit toolkits out there, a lot of their stuff is really oriented around 32-bit. Either the brute kits they come with are 32-bit, or the shellcode libraries they come with are 32-bit, and you'll see those things revamped for 64-bit as well. So at some levels, we have a slightly better place to start with 64-bit, and that's great. And we continue to do that differentiation of, as we develop security enhancements, turn them on by default for 64-bit where we can, and then go opt-in if we absolutely have to on 32-bit for compatibility. The next trend I'm going to talk about, I call it architectures of safety, or you can think of this as sandboxing or compartmentalization, but this is really about partitioning the system so that if you have a break in one area, it doesn't lead to a full break of the system. If you think about the shift from Windows XP, where an attacker needed exactly one vulnerability and they were pretty much root on the box because everybody ran as admin, to the world of Vista and Windows 7, where a lot of users are now running as a standard user and they need to get code running, and if they want to elevate and take over the box, then now they need 2 different kinds of vulnerabilities. Well, with sandboxing, they're going to need at least 3 different vulnerabilities in different areas of the system to pull off a full attack. Windows has, for many years, introduced components that make compartmentalization possible. Job objects, restricted tokens in Windows 2000. Vista introduced integrity levels in UI, PI. And this Windows essentially provides a toolkit that applications can use these things and pull them together to make a sandbox for applications. One of the best examples I like is the Office 2010 Protected Viewer. This was done by David LeBlanc and Dan Jump. And if you open a document from an untrusted source, you'll see this ribbon across the top. And what that's doing is, if you actually go look at a normal token of PowerPoint and then compare it with the one running into the Protected Viewer, you'll see that they utilize, for example, restricted tokens. And here they take a number of the SIDs that are otherwise quite privileged and mark them for deny only. They also make use of restricted SIDs and restricted tokens. You can see here it's running at the low integrity level. and they've also stripped all the privileges. They do a few other things in their sandbox that was quite nifty, but sandboxing was something that it used to be sort of an experimental thing. People would try it, and then finally with looking back to IE7 and protected mode, that really started to bring this stuff mainstream for Microsoft. And then Office started with their MoIce technology. You see Google Chrome pick it up, Protected Viewer shows up, and then Adobe has announced that Adobe Reader in some fall release will have a protected mode that's largely based on what they learned from both the Office one and the Chrome one. And so we've gone from a world where things were running as admin to things running as standard user to things running in these compartments. And if you look to, I didn't really talk about mobile phones here, whether it's iPhone or what have you, you'll see sandboxes are on all of those things as well. And so it is just part of the architecture now for at-risk applications. The next trend I'm talking about is robust mitigations. So mitigations are this defensive technology that we've been building at Microsoft for about the last 10 years, ever since Trustworthy Computing, to try to deal with memory corruption vulnerabilities. So back in the day, that was the original /GS flag in the compiler. That was stack cookies, things like data execute protection, address space layout randomization, and there's a whole bevy of these things that we in conjunction with product teams have been incubating and delivering and putting into the compiler, putting into the operating system, putting into applications. And the goal of this stuff is to provide some of those seat belts and airbags in the case of a vulnerability gets through the process and is attempted to be exploited in the wild. The goal is to make exploitation unreliable, to up the cost to write a reliable exploit, and just make exploits brittle in general. Fortunately, at Microsoft, we have the SDL. The SDL lets us take these things and make them eventually mandatory part of the SDL, and that's how products at Microsoft ship with all of these things there. We have a whole bunch of things in incubation I can't tell you about right now, but a lot of active work in this space. If you look at third-party applications running on Windows, you're starting to see them take advantage of this stuff. It's not anywhere kind of where we want it to be, but in some sense, the most security conscious of ISVs are starting to put these things in place. And it's interesting that the latest Adobe Reader, it compiles with GS, it has data execute protection turned on, it uses ASLR in almost everything. And the almost was an important thing because their recent cool type 0-day that was released, the attackers actually took advantage of the fact that one of the modules that came with it was not marked for ASLR, and that was what they used to do their return-oriented programming to get code execution from XP all the way to Windows 7. So doing this stuff and doing it across the board is super important, and we continue to work with ISVs to get them to adopt it as well. We recently released a tool called EMIT, Enhanced Mitigation Experience Toolkit, and the way you can think about this is if you have legacy applications that aren't being developed anymore, you can't recompile them, this is a way to bring those new mitigation technologies onto those legacy applications to improve the level of security that they have. There's a talk on this later, you should definitely see it, by Andrew Ross and Fermin from MSRC Engineering. We found that this was effective against that Adobe 0-day, and a lot of customers downloaded it to help protect themselves while that thing was going around. But the bottom line is, even though we're still filling in the pieces here, if you will, but the bottom line is over the next decade, we'll have a pretty robust set of these mitigations, and applications will have revved to the point where they have a pretty complete set of these things. Every vulnerability is different and presents different opportunity for exploitation, so fix your bugs, please still go ahead and fix your bugs. All that stuff is super important, but the defensive capabilities are getting better, and that trend is going to continue. The next trend is smart devices. 10 years ago, I probably interacted with basically one operating system, and that was my PC. And nowadays, if you look around, it's their smartphones, their music players, people that have medical devices, if they're diabetic or what have you, doing stuff. There's all these different operating systems in cars to help with navigation and things like that. I mean, the number of operating systems you interact with, the number of chips, different chip architectures they run under, it's actually pretty diverse, and it's just getting even more diverse as technology finds a way to fill all these niches to make our lives more social, more productive, more convenient. And this is just going to keep going. These devices are interesting because they run a bevy of different things. Some of them have credentials to maybe your corporate network. And then in that sense, they're essentially an authenticated device, and they have essentially a full-featured operating system on there, listening on multiple networks, Wi-Fi or not, cell network possibly, various wireless ones. And the thing that's, I look at this trend that's interesting is we sort of, in Windows we were, I don't know if you want to call it fortunate, but one fact of our life is we grew up with the adversaries. We grew up with people, as we improved our security, the counter techniques and the attack techniques improved with us, and we absolutely had a co-evolution that's been going on the last 10 years. And now you have people that know about all these exploitation techniques because they grew them on Windows, and they go look at these other platforms, and they have no mitigations, no way to update, and it is really those platforms developing this stuff and putting themselves out there need to be ready for that level of adversarial attention. So definitely an interesting set of things to watch here. The next one is modernization of the web. If you're paying attention at all what's going on with IE9 right now, there is a renaissance going on in the web. There's a whole bunch of new standards-based technologies coming out there, from HTML5, Canvas, video, scalable vector graphics, GPU accelerated stuff. And we're moving from a world where all of the special content was locked up in plugins to that is just the way the web works now, from your desktop and eventually to mobile devices and whatnot. The great thing about this is there is a lot of excitement about this new world, and we have a huge part of our installed base on these really old browsers. I was in Beijing about a month ago, and the population there that's on IE6 is just incredible. It's like 80% of the population is still on IE6. And part of this is this revitalization of the web is going to drive a huge set of upgrades to people running modern browsers, and that is a very good thing for a lot of reasons. With this modernization, there's a big focus on performance to get the interactivity. This is one interesting thing the IE team is doing. If this is one particular benchmark for JavaScript, it's not the most important, it's not the be-all, end-all benchmarks for JavaScript. But if you look at IE8 performance in JavaScript, where higher is worse and higher is slower, and you look at where the Chakra JavaScript engine is in IE9, I mean, it's among the best, and it's almost so it's imperceptible, the difference here. And that's really a credit to DevDiv and the team that's building that component for IE. Part of the reason they get this boost is they do what a lot of other browsers are doing, is they take your JavaScript and they compile it to native code. So in IE9, your JavaScript is getting JITted to native code while you're browsing. And jitting JavaScript to native code comes with potential security things we worry about, because anytime you can increase the amount of executable code in the address space, especially if the attacker can influence what code is generated, that presents opportunities for them to bypass data execute protection. So there's a class of research that's out there. It's called JitSpray, and it's about using jitters, whether they be JavaScript engines or Java itself or Flash, in order to get past data execute protection. We knew this stuff was coming. Matt Millers and others have been tracking that space for a while. And so there's a number of mitigations in the IE9 beta to deal with this JitSpray. There's a couple I'll just highlight here. If you go and actually look at the JITted code inside your Internet Explorer process, you'll see a few things that are otherwise, sort of strange to be in JITted code. The first one is showing an example of a random NOP. And what that is doing is it's essentially inserting no-op equivalent instructions in there to break the predictability of the code that gets generated. It has essentially no effect on performance, but it does have an effect on the predictability of the code gen. The second one is what we call constant blinding. A great way for the attacker to influence the generated code is to use a lot of constants in their JavaScript. You can think about maybe a JavaScript function that all it does is add some D-word constant over and over again, maybe 1,000, 10,000 times. And when that gets JITted to native code, well, that constant would typically show up, and that's a great amount of influence they have over the generated code. Well, and they use that to get code execution. What constant blinding does is it takes all of those constants and it essentially masks them, so there is no difference at the arithmetic level, but to the code gen level, it's unpredictable for the person doing the JavaScript what that actually is going to turn out in terms of a code gen. So these are the performance of the web is super important these days, but because we participate in the security community and attend the conferences and talk to researchers, we watch the space and see these things evolve, and now the products come with these things built in, and we don't have to go add them in after the fact. So some really nice work there. I couldn't get through a talk about trends without talking about cloud computing, so here it is. We're definitely moving to a world of utility computing. and an era where there will be a relatively small number of companies that will have essentially super data centers and be able to run the stuff at truly phenomenal scale. We're already seeing attackers out there take advantage of cloud computing in a few ways. One thing as an attacker that they've always had to worry about is the infrastructure with their attack. They want to go mount some attack campaign somewhere. They need command and control nodes. They need nodes to go act as drop points for data exfiltration. If they want to go attack another country, they have to like find machines in the target country, knock them over, set up their stuff, have to worry about is it still there? Can they depend on it? And with cloud computing, they can just go whip out a stolen credit card, and now they have like high bandwidth, dedicated hardware to go mount their attacks. And we see different cloud resources, different cloud providers' resources being used in essentially cyber crime. It also enables, because it's utility computing, things like cracking passwords. That could be passwords for accounts, that could be passwords on Excel spreadsheets. It just becomes a simple economic equation. Because you don't have to do the capital investment to build out a lab, you just say, well, how much is that Excel file worth to you? Okay, well, you go buy the compute cycles from Amazon or what have you, and then you get it. It's just simple economics at that point. There will also be a challenge in forensics. If you think about people in the forensics world, chasing down an IP address today is a real pain in the butt because of how it can move around. Well, that'll be similar in the cloud, where even if an attacker is using this particular cloud server over here, that might be on a virtual machine that rotates from machine to machine to machine, that eventually just turns over, and essentially hosts become as ephemeral as IP addresses, and that's going to provide some challenges. The next trend I'm going to talk about is vulnerability disclosure. Microsoft, we have a lot of needs to serve in the area of vulnerability disclosure. Governments want to protect their national critical infrastructure. Customers want 100% bulletproof updates. You heard MSRC talk about that and how crucial that is. Security vendors, they need good technical quality information so they can provide intrusion detection, intrusion prevention signatures to customers while they're waiting to deploy those updates. So at Microsoft, we've sort of changed our language here from responsible disclosure to coordinated vulnerability disclosure. And it really emphasizes the security vulnerability finder and the vendor working together and coordinating together. And when they do disclose it, an emphasis being there on mitigations and workarounds. We think we actually do pretty good in terms of vulnerability disclosure. If you look at the Security Intelligence Report, 80% of the vulnerabilities that we deal with are responsibly reported to Microsoft. And I think that's really a credit to the MSRC in that they're a good response organization to work with, and that gives us repeat customers that are these vulnerability finders doing some really good work. There are some trends that we're observing, and this is definitely a pretty active area. One is that as finding vulnerabilities gets more difficult, it really becomes an opportunity cost for bug finders to spend their time. And so we're seeing other vendors incent them with dollars to essentially go attract those top-tier researcher cycles to go spend time with them. And then the next one is we're also seeing other vendors where normally they would disclose vulnerabilities that they find to Microsoft, where now some of them are thinking, maybe we just won't do that. We'll have a pay-for service. We'll sell the vulnerabilities to our customers, but we won't give them away to the vendors anymore. And there's a concern that those vulnerabilities will get increasingly locked up, and so that's something we pay very close attention to. And then the last trend that's pretty active is around time to fix. Vulnerability finders want those protections out to customers as soon as possible. Microsoft, we do too. You heard from MSRC about all the challenges in putting those updates out. And so it's hard to set arbitrary deadlines around, because each circumstance with each vulnerability and updating it is very different, as you've seen. And so, but that time to fix pressure, and plus just the desire for Microsoft to get those protections out sooner, that we're going to have to find a balance there, and we're constantly focused on how to improve that. And the last two trends here are cybersecurity sort of had a bad reputation about 8 years ago, and it's really gone through a rehabilitation, and that's largely because, indeed, attacks have gotten worse out there, both from cyber espionage to cybercrime to Stuxnet to what have you. So governments around the world, they recognize the benefits that information technology brings to their society, from productivity and whatnot, but they need to manage the risks around it. So there's a team under Paul Nicholas. They're tracking over 50 countries that are drafting legislation in various forms that over the next 18 to 24 months are going to pop out legislation on a whole range of cybersecurity related issues. And that ranges from supply chain stuff to should cyber professionals require certification, should they need to get certified like lawyers and doctors do, to how do we share information from private and public industry and whatnot. And all of these things will affect Microsoft, and it's going on all at the same time all around the world. And the last trend I'm going to talk about is loose cyber weapons. The internet is certainly a unique battlefield, different than any other battle space. And if you look at a lot of our zero-day vulnerabilities that have shown up in the wild, I'm going to underline the ones that when we look at them, we can attribute that back to cyber espionage of some kind. And you can see here that is cyber espionage is the driving force behind the zero-day vulnerabilities that we have to respond to as attacks in the wild. And so the world is changing around us. And this stuff is being increasingly used by many, many more actors. And if you look at Stuxnet, when Stuxnet came out, the response by a lot of people was, if that's the way this stuff is going to go, then we need to go get involved in that too. And our products are absolutely in the crosshairs for this stuff. Interestingly enough, the Adobe Zero Day that showed up just a month ago that they just recently patched, I mentioned earlier, it used a return-oriented programming technique, and that vulnerability was used in cyber espionage at the beginning of its campaign before it became widely known, and then it was just used by cybercrime and whatnot. But those return-oriented programming techniques, you guys heard about that at BlueHat first. That came, if you go to conferences, you heard about it there. But we talked about that at BlueHat last year. There are talks on it this year. And what happens in the research community and the active research there shows up in the real world. And so it's important for you to continue to come to BlueHat, and I'm very proud that all of you have chosen the time to come here today to pay attention to this stuff and to learn and dialogue with researchers, because this stuff absolutely affects our products, and this trend is just going to continue. And with that, those are the 9 trends that I have. I want to thank you for listening to me.